Hi, in this video, we're going to put together what we've learned so far this week in terms of importing data into R, various data types and classes, and recoding data to make a visualization that we improve sequentially as we apply these transformations. The case study that we're going to be working with is data on religion and income. So this comes from the Pew Research Group that does a survey on people's religious tradition and the income that they make. So this is data from the United States retrieved in April 2020. So somewhat recent data we're working with. This is the data set that they make available on the Pew website, and they actually have a button to download this data set. So that's what we're going to be starting with, where each row is a religious tradition, and then we have columns for various income levels, and the percentages in those income levels are in the cells. So we've saved it as an Excel file that we can read in using the read Excel function. And as we read it in, we see that we end up with a table with 12 rows and 6 columns, which should basically match the screenshot from the website that we were looking at earlier. And I'm going to call this data frame rel inc. So that's what we're going to be referring to it throughout the video. The first thing I want to do is rename some columns. So let's go back for a second. The first column was called religious tradition with a space in it. And then I also have somewhere a variable called sample size. And I want to change that with n so that it becomes a little bit easier to refer to. For this, I'm going to use the rename function from the dplyr package. And the way we use this function is the syntax is the new name equals old name, and in this case, since the particular old name has a space in it, we have to quote it. So that's what we're doing here. You might be thinking, why didn't you change the other variable names that are also pretty wonky as well, like $100,000 or more and stuff? But we'll get to that in a second. We're actually going to be using those not as variable names, but by pivoting the data. So that's why I didn't touch them for the time being. But with this rename, I have religion. That's all lowercase, and instead of sample size, I have n. Now, if we want a new variable called income with levels such as less than 30,000, 30,000 to 49,999, etc. And so basically I want my output to look like what we're seeing here on this slide. Which function should we use? So originally our data set looks something like this, where we had 12 rows and 6 columns. And what we want is a data frame with 48 rows and 4 columns instead, where basically the various income levels are not spread across the columns, but are actually stacked on top of each other. So we're going from a wide data frame to a long data frame. So we would use pivot longer. And the way we're using pivot longer here is, remember, there are 3 arguments we need to specify to it. The first one is cols, which is which columns we want to pivot. So I want to say I want to pivot everything other than religion and n. So the religion was the religious tradition column, and n is the sample size column for the survey takers in those particular religious traditions, and the rest were the number of people that fall into each income bracket that's in the survey. So here I'm saying I want to pivot everything but those 2. The names from the columns that I'm pivoting, so those are the income amounts, are going to now go into a new column called income. So the names will go to a new column called income. And the values from the cells, those were proportions, so I want to put them in a new column called proportion. So my data set looks something like this. I have 48 rows, which is basically 12, the number of religious traditions, times 4, which is the income bracket, the 4 income brackets for which we have data within each religious tradition. Next, what I want to do is to calculate the frequencies. So I have my sample sizes in the column called n, and I also have my proportions. So by multiplying the 2, I'm going to calculate frequencies. I'm going to be honest here, I'm being a little bit sloppy because it's possible that for some of these religious tradition groups, maybe the sum of the frequencies don't necessarily add up precisely to the sample size because of rounding error, because here here, the way I'm calculating the frequencies is I'm saying multiply proportion times n, and then round it. And when you use the round function with no additional arguments, it's basically going to round it to the nearest whole number. So when we add these up, we may not necessarily hit that particular number for some of the brackets. So that would probably be something I should be fixing manually, but I'm going to omit that for the time being and say we might be good enough. And again, we created a new column in our data frame. So we mutated our data frame to add this new column called frequency. Now that I have a data set that I'm happy with so far, I'm going to save it. And I'm going to save it as rel inc long. The first data frame I had to begin with was rel inc. That was the wider data frame. So now I've pivoted this to be longer, and I've added this new column that I'm going to use for my visualization. All right, let's make a bar plot. Let's start there. I have my data frame as the first argument in ggplot. In my aesthetic mappings, on the y-axis, I have my religion, and on the x-axis, I have the frequencies that I just calculated. So I want these bar plots kind of sideways as opposed to vertical. And the reason for that is the names of these religious traditions are pretty long. And if I had them stretched across at the bottom, they're probably going to overlap and be hard to read. Putting them at an angle or something seems not as pleasant as being able to read them as lines like you would with regular text. So that's why I've chosen to put the categorical variable on the y-axis and the frequency on the x-axis. I am using a function, a geom called geom_col as opposed to geom_bar. And the difference between these two is that when we have data where each row is an observation, so not summarized data, we would use geom_bar because that will first do the counting for us for each of our buckets to determine the heights, or in this case, the lengths of these bars, and then plot them. But in my case, I don't actually have data from individuals who responded to the survey. I have basically what I could call a summary table. For each religious tradition and income level group, I have the frequencies of the number of people that fall into that bracket. So since that summarization has already been done, I am in building my bar plot. I am giving it an X aesthetic that will determine the lengths of these bars, and then I'm using geom_col as opposed to geom_bar. Now, the next thing I want to do is mess with these religious tradition levels a little bit. Some of them are a lot longer than the others, which I think makes it a little bit hard to read. So I am going to replace some of the character strings with slightly shorter character strings. And since I'm saying sum of as opposed to just one, I can use a case when statement where I basically figure out for particular character strings, like evangelical Protestant, historically Black Protestant, and unaffiliated religious nuns. And we are basically replacing those character strings with something a little bit shorter. So we've seen the case when function before, but I want to go over it one more time. So I start with my data frame, and I'm doing a mutate because I'm changing my data frame and specifically touching on the religion variable. And note that the variable that I'm basically creating is one that already exists, so I'm overriding the existing variable. And the way I'm overriding it is by a series of 4 conditions that I'm going to check for. So these are the cases, and when that case is true, we want whatever I said on the right-hand side to happen. So if religion is equal to evangelical Protestant, then I'm going to recode it to ev.Protestant, so something a little bit shorter. If religious is equal to historically Black Protestant, then I'm recoding it to hist Black Protestant. And if it's equal to this character string, then I'm going to recode it to unaffiliated. Now I want to draw your attention to something here. In this particular character string in my data set, I already had some quoted text, right? So because I already had some quoted text, I chose to use single quotes here as opposed to double quotes, as Otherwise, the two character strings are going to get messed up. So you can use either single or double quotes for denoting character strings. The style guide that we're using basically recommends using double quotes. So that's what you're going to see me use. And that's, I think, what you're going to see used commonly with our code. But there are instances where you may want to revert back to using single quotes because the character string you have already has quoted text that uses double quotes in it. So that's that. So these are the three conditions where I'm saying if it's one of these long phrases, then make it something shorter. For everything else, so the way I denote that is by saying true, meaning if the first three conditions fail, then call everything else true. So for all of the other religions, we are going to basically leave the value alone as it was. So keep the old value of religion. So if I plot this again, I basically see the same plot as I saw before, but some of the text is shorter. So for example, that unaffiliated text was a lot longer earlier. Now, the other thing that I might want to do, let's go back to that plot, is you can see Buddhist, Catholic, Evangelical, Protestant. So we're basically reading up to go down the alphabet, which seems a little bit odd to me. So what I'm going to suggest is that we actually reverse the order here. So Buddhist starts on top and then RI goes down to unaffiliated. So they're in alphabetical order, not a different order in which these are placed, but it's currently appearing to be in reverse order, which maybe mathematically kind of like makes sense if you had a y-axis smaller to larger. But when you have character strings, it doesn't, I think it's not as clear why that order was chosen. So what I want to do is reverse the order of these levels, and I don't want to have to write them out one by one. So here I'm going to use another function from the forcats package, which I know is denoted by the prefix fct, and basically the function I'm using is fct-rev for reversing the levels of the factor. So I don't have to write all of them out one by one. I'm basically saying mutate again the religion variable and reverse the order of the levels in that variable. And so now the plot is the same, except the religion levels have been flipped. Next, let's add the income information. So now going from a bar plot, I've gone to a segmented bar plot where basically the lengths of these segments denote the various income levels. And let's go ahead and take a look at the code here. In order to do that, I've basically filled the various the bars with the income level information. Now looking at this, we might think, okay, I wonder if there's difference in the income distribution within various religious traditions. But that question is really hard to answer from here because some of the religious traditions have a lot more, a much bigger sample size because they're simply more common than some of the other ones. So comparing these frequencies across the bars is not really a good way of coming up with some decisions about how does income level vary across people who believe in various religious traditions. So if we want to do this comparison across the various religion levels, we're going to want to expand these bars so that they're actually showing the proportions as opposed to the frequencies. That's what we had started with earlier, so we're kind of coming full circle here. And the way we can do this is by adding the position fill argument to our geom call. So position fill will basically expand the segments such that the length in this case of each bar is 1. And then the lengths of these little segments are going to be the proportions of these income levels as opposed to the frequencies. So we can kind of see, for example, that among Buddhist, Catholic, and Evangelical Protestants groups, the proportion of those who make less than 30,000 is roughly the same versus that proportion is much higher in historically Black Protestant or Jehovah's Witnesses, for example. So we can start making these sorts of statements based on our data when we're looking at proportions as opposed to counts. The code for doing that, we said, is basically just adding in the position fill argument. Next, let's change up the colors. So instead of using the default ggplot2 scale, I'm going to use the Viridis scale. Note that I'm changing the colors that I used for the fill aesthetic. So that I can do that using scale fill Viridis, and then the _D at the end is for discrete as opposed to a continuous scale. And then I'm going to change the theme. The default ggplot2 theme is the theme gray. So we can see this kind of the gray box behind these bars, which I think looks a little bit busy. So let's go ahead and make that a little bit cleaner using theme minimal. So again, we're adding that on as another layer here as well. And finally, I'm going to move my legend to the bottom from the side so I can get a little bit more real estate on my visualization. And the way I can do that is basically, let's look at the code. I'm moving the legend to the bottom in the theme layer by changing the legend position to bottom. So now we're basically entering into territory where we're really customizing our plots. And some of these things that I'm showing you here are not things that you should expect to kind of know by heart versus, you know, how do I do aesthetic mappings? At some point, you'll have done enough of these that you're probably going to get to a point where you're able to do them without looking at the documentation. But these more kind of specific customizations for moving legends around or changing the look of your plot are probably things you're going to keep looking at the documentation for to implement from time to time. And that's perfectly fine. But the important message here is that these are all possible. And what it takes is reading the help file to figure out how it works. And sometimes when you read the help file, it's not even clear necessarily how it works. So you might actually want to implement it and see what you get and see if you like it. So now I've basically moved my income, the legend of the income level to the bottom. And the next thing I'm going to do is I'm going to make that into 2 rows so they feel a little bit more compact. So you can see that the legend was expanded across 1 row, and now that is in 2 rows here. And the way I can do that is by in the guides layer. So basically I'm saying that the legend for the fill aesthetic should have 2 rows and fill them up by row. So basically fill up the space that you have for the 2 rows by placing the various levels next to each other as opposed to by column. And let's see, we have 1 more, and let's fix up the labels. So here I have gotten rid of the Y label. As you can see, I've given it an informative title, and I've indicated my source, and I've also changed the X-axis label and the label for the legend as well. And that all is happening in the labs layer, basically setting the character strings for the various labels that I want to replace in my plot. So ultimately, we started with a plot that looked kind of not very informative, and also that was driven a lot by the fact that certain religious groups had a higher sample size than others. And incrementally, we've gotten to a point where we're able to make much more kind of useful statements about how various income levels compare across various religious traditions. So we can see, for example, which religious traditions have the highest proportions for lower income. So here it seems like historically Black Protestant and Jehovah's Witnesses. And then we can also make comments about which particular religious traditions have a higher proportion of people that are in the higher income brackets. Could we improve upon this visualization? Sure, this video could keep going forever. But what I wanted to convey in this video is that we've learned these bits and pieces of tools, all these functions for working with factors and reading data in and customizing how we do all of this stuff. And in the abstract, that might just look like a lot of information. But once you start putting things into use, and you can see how we can use these functions incrementally to improve our visualizations, to improve our summary tables, and down the line to improve how our models are fit. Hopefully this will all start to feel more like useful tooling as opposed to too much tooling.